Hi there, and welcome back. So let's take a look at computed properties. So read-only properties are actually quite common. Write-only properties, I showed you that in the previous code video, those are not very common. They can certainly be used, but it's really more common to use read-only properties. So here, I'm going to focus on computed properties, not computer properties. So let's take a look at an example. Let's say that we have a circle, and a circle is going to have a property of radius, and I'm going to make that a bare attribute, and then it's going to have another property called area. Now I could make that into a function, but I prefer the syntax where I don't make a function call to get area, and as I was showing you in the previous video, I really would prefer that to be a property. To me, area is a property, it's not a method on the circle. So let's go ahead and do that. So from math, I'm going to need pi. So let's import that and let's define our circle class. So in the init, I'm going to do self and radius. I'm going to pass in the radius and I'm going to store that in a bare attribute like so. And then I'm going to create a property. So I'm going to use the decorator syntax and I want the property name to be area. So self. And let's just print this, calculating area. And then what am I going to do? I'm going to calculate it. So this is not a stored property, right? This is a calculated property. Every time you access the area property, it's actually going to run the getter, and the getter is going to run a calculation and return that value. So I can create a circle instance, and then I can call c.area. Well, first of all, I can do the c.radius, that's just going to return the attribute value. And if I look at the area property, of course, that is a property now, it's going to call a method. It's going to call the area method. And as you can see, we get calculating area and we get the value of the area back. Now, we could just use an area function, right? We could just basically make it a method, do this. There's nothing wrong with that. The only difference now is I have to call it this way. So it may be a personal preference. For me, area is more like a property, right? An attribute of the circle rather than just a method. So I would rather call it that way, in which case the only thing I have to do here is just prefix it with the property decorator. So this is nice, but there are some issues here. And the thing is that every time I call area, right? So let's go ahead and redefine this class, make sure we've got the same code running. So it calculated the area. If I call area again, it recalculated the area. So every time I basically invoke area, it's going to recalculate it, right? So that's not very good, because if we have a case, let's say, where we create, a couple of circles in our program and then we access the area thousands of times for the same circle and we never change the radius, having to recalculate it every time is a waste. So we really would only want to recalculate it if the radius has changed. If the radius hasn't changed and we've already calculated the area, we don't want to recalculate the area every time. So how are we going to know if the radius has changed? Well, a property. We're going to use a property to keep track when the radius is being set. And then we're going to cache the area itself, and then if the radius hasn't changed, we'll just pull the value out of the cache. If the radius has changed, we'll recalculate the area, put it in the cache, and then use that. So let's go ahead and implement that. This is kind of an interesting use case, and it's a very common one too. So let's start with our circle class, and now we're going to do our init. So we'll pass in self and radius. So the first thing is I'm going to store radius in a private variable. Pseudo-private, of course. So this is one of those cases where if people actually access the underscore radius directly, this will actually break the functionality of our class, as you'll see in a second. Next, I want to use also a private variable to hold the area for the circle. But I will have two states for area, for that underscore area. Either none, which means the area hasn't been calculated, I need to calculate it, or it has a value in which case I can just return the value. It means that the area was calculated and it's correct for this particular circle. Okay, next thing I need to do is to create now a property for radius. So I'm going to create the getter first. So let's call it radius self. And all we do here is just return self._radius. So now I need the setter for the radius. So I'm going to do radius.setter and then def radius. Again, I have to keep the same function name and the new value for the radius. So, I mean, there's things that we could do here to make sure that the value, for example, is, greater than or equal to 0. We can't have a circle of a negative radius, those kinds of things. But I'm going to keep it simple. For now, what I want to focus on is this caching issue. So if I'm changing the radius, I want to make sure that my area cache is not valid. So I need to set it to none. So the first thing I'm going to do is to say, hey, self.area is none. In other words, it will need to be recomputed when it's requested. So I invalidate my cache, essentially. I clear my cache. And then the next step is to set the radius value, and I'll set it to value. Again, I'm not doing any kind of validation here. So now I need to define a property for my area. Now I am not doing any validation on the radius. So for example, the radius could be 0. Normally I would put validation on the radius and say, hey, you cannot make a circle of radius 0, for example. So depending how you do it, how you test whether your cache is valid or not could be, could change. Here I'm just going to say if self._area is none. So if it's none, what does that mean? Well, that means that I didn't calculate the area, right? My cache isn't filled with the area for the current circle. So in that case, I'm going to print calculating area, and I'm going to calculate the area. Self.area equals pi times self.radius. Now you'll notice that I'm accessing the radius through the setter. I could be accessing it directly using the underscore radius. But again, it's usually better to access things through a property if you've defined the property. Because if this had any other pieces of code that it was doing in order to get the radius, then you would actually benefit from that code right here. Now, right now, it'd be fine. It'd be just fine to do this. But if later, let's say I come back and I say, hey, when I return the radius, I'm always going to return the absolute value of the radius. That way I'm forcing radiuses to be positive. Then if somebody provides a negative value for the radius, it will set underscore radius to the negative value, and I would get the negative value over here. So this is kind of a contrived example, but that's what I mean by that. So instead of doing that, I tend to choose to use the property itself, even inside my class. So here, I'm going to set the underscore area, the private variable, to that squared, like so. And let's be explicit with the parentheses. Now, once I'm done with that, either my area was none and I calculated it, or my area was not none, I didn't calculate it, but in either case, I can now return self._area. So that's now my circle class, and I have caching for the area property. So let's go ahead and try it out. So let's say I create a circle with a radius of 1. Now I call c.area, it calculates the area and returns the correct value. If I call c.area again, you'll notice it didn't have to recalculate the value. It already had it in the cache, and it just returned the cache value. It didn't print out calculating area. Now watch what happens when I set my radius on my circle to 2, right? So now I've mutated that circle. I've changed the radius. What happened? Well, it went through the setter, which means that my area is currently none. If I look at C, dict, you'll see now that my area is currently set to none. That was set to none by the setter. So now I can go ahead and call area, and what happens? It recalculates the area because it needed to. But if I call it again, it's no longer recalculated. So this is a way in which we can use these getters and setters to do more than just have validation. This is a very common example of where we can use getters and setters to invalidate caches, to do calculations and only do calculations again when it's needed, and so on. This is a typical use case. Now, there's a lot of other uses for calculated properties. I mean, some properties may even do a lot of work, like retrieving data from a database, or maybe creating other objects and doing various things, maybe calling an external API and so on. So properties are not, they're functions. They're essentially methods. So they can do a bunch of stuff. That's not just a single value in some backing variable necessarily. So let's do an example that's a little bit more interesting. Let's write a class that takes a URL and then, as a property or an attribute, we'll see how we want to do it. And then it will download the web page for that URL, and it will provide us some metrics on that URL, like how long did it take to download, what was the size of, in bytes of the page, and so on. So I'm going to use built-in libraries of Python. So here I'm going to use the URL lib module, but if you're going to be working with URLs and making requests and things like that, I really strongly suggest that you use the requests library. It's a third-party library, but it might as well be part of standard Python because it's very, very commonly used. So I would suggest that you use the requests library. I have the link in the Jupyter Notebook that you can download. But for this example, I don't want to have to install requests, so I'm going to use URL lib, which is a little bit more difficult to use, but it's not bad. So let's import URL lib, and then I'm going to want to time how long it takes to download the page. So from time, I'm going to import perf counter. So I'm going to use that to time things a little bit. And let's go ahead and write our class. So I'm going to call this class web page. And we're going to have an initializer, and in the initializer we're going to pass it the URL. And here for the URL I'm going to make a bare attribute. So self.url equals URL. And let's go ahead and say self._page equals none. And self._load time in seconds equals none, and self._page size equals none. So these are the things that are going to be calculated. Now I use self.url equals URL, but if you think about this class, I'm going to specify the URL, and then later I'm going to want to be able to call up things like the page, the load time in seconds, the page size in bytes, and so on. So I kind of need to know when the URL changes. If somebody changes this URL, these values here are no longer valid, just like the area on the circle. So it looks like I'm using a bare attribute here, but I want to actually make that into a property. So I'm going to go ahead and make that into a property, def URL self, and that's just going to return self._URL. So I am going to use a private variable. What's happening here is that I'm actually going to be using the setter method. So I want URL.setter, and I'm going to define the URL setter function now. So self and value. And what am I going to do in there? Well, what I really want to do is I want to set my underlying value, URL, to this value, and I'm going to set page equal to none. Okay. So we'll lazy load the page. So we're not going to load the page from the web until somebody actually requests it. So even though they set the URL, they may never request any of this data over here. Let's not do the work ahead of time. Let's delay until it's actually needed. So we're going to be lazy here. So now what do I want? Well, I want a page property. I want to define a property for the page. So let's go ahead and do that. Now, if self._page is none, so if the page is not loaded, basically, then I'm going to call this method called download page. And I haven't created that method yet. I will. And once that's done, then I'm going to return whatever's stored in page. So basically, my download page is going to take care of downloading the page and setting various things in the class, and then I'm going to return the underscore page. If the underscore page was already there, then I'll just return whatever's in cache. So this is my cache. Essentially, it's no different than the area. This is just a little bit more of an expanded example. Okay, so we have that. Now let's go ahead and write another property, and this one is going to be the page size. So the page size property is going to be, again, a read-only property, right? Page is going to be a read-only property. I'm not going to define a setter for page. I'm not going to define a setter for page size. These are calculated properties. So if self._page is none. So again, I'm going to check, was the page downloaded when the page size is requested? If it wasn't, then again, I need to download the page, okay? So I'm going to call download, if I type it right, page. And once that's happened, I know that the _page has been populated with the page. And now I can just return self._page size. So where is that going to get set? I'm going to do that in the download page method. So the download page method is going to take care of downloading the page, setting the _page attribute to that value, calculating the page size and storing it in the _page size value. And then we're going to do the same thing with the time as well. So I try and keep my properties as simple as possible. And then I'm going to offload the work to another method that's going to be a little bit more complicated. So here we're going to do essentially the same kind of thing. We're going to check the cache. If the cache is none, if the page is none, that means we need to download the page. And it's going to do all the heavy lifting. And then after that's done, then we know that we're going to have the self._load time in seconds. That's when I'm going to use that, right? I was using that as my private variable. I'll just return that, counting on the fact that this will have populated that value. So that's that property. So we're done now with the interface of the class, basically. Now I want to create this download page method. So we can go ahead and create it, download page. Now some people will actually write this as an _download page to indicate to the user that, hey, this is an internal method, please don't call it, because it's really going to get called as needed, so you don't need to touch this function. But to me, it doesn't really matter if the person wants to call download page because they want to refresh the page, then we should probably give them that option. So I'm going to leave that and not indicate that it is a private method because it's not. And there's other things that we can do on this class. We could have a method that's maybe called refresh page, right? And then that's going to call download page. And then at that point, we could definitely make it private and so on. It kind of depends how you want to define your classes. So what are we going to do when we download the page? Well, the first thing is I'm going to clear out whatever I have for page size. So I'm going to set it to none. I'm going to do the same thing with the load time in seconds, and actually, in seconds. And we'll say none. And then we're going to say start time equals perf counter. So I'm going to start the timer. The next thing I need to do is I need to download that page and read it. So we're going to use URL lib, and we're going to use the request.url open. So if you want more information, you can go ahead and read up the documentation on URL lib. But if you're going to be doing requests, I would really suggest that you use the requests library instead, much simpler to use. So we've opened that URL, which was the self.url, and then I'm just going to retrieve the page. So self.page equals f.read. I have to read it to read the whole thing in. And then the end time, now that we're done, is perf counter again. So now we have our start time and our end time. Okay, and now we have the page as well. So I'm using this self._page, right? That's going to get accessed here by the page property. So now that I've got that, I just need to do my 2 extra calculations. Remember that I said I was going to count on download page, calculating the page size and calculating the load time in seconds. So I'm going to reference it here. So I'm going to say self._page size equals the length of self._page, and then the self._load time in seconds is just the end time minus the start time. And that's it. That's all I need really for a pretty simple implementation. There's lots of other things we could do, but this is a pretty straightforward implementation. The download page does everything we need. It uses the current URL, downloads the page, does the calculations for page size, load time in seconds, stores the value for the page itself, and then we have our interface in our class that basically is, what the user is going to use. They're going to use the URL property, they're going to use the page property, the page size property, and the time elapsed property. So let's go ahead and define a few URLs. So I'm going to make a list of them, and let's say HTTPS, and we'll go to standby google.com. So we'll read the front page basically of Google, the home page of google.com. We'll do the same thing with the python.org website. So let me see if I can type this right. And then the next one that we'll do, let's do the Yahoo. So https www.yahoo.com. Okay, so we're going to basically load up and these three URLs and then just compare what's going on. Okay, so now let's go ahead and iterate through all these URLs. So for URL in URLs, and we're going to create a page for each URL. We're going to create an instance of web page. Now keep in mind that the page hasn't been loaded at that point. If I do this and run it, it's like instantaneous, because all it's done is just created those instances of web page and it stored the URL in each one, but it didn't do any of the loading, which is great because now if I don't call any other of the attributes of the properties, then it's never going to actually download the page. I'm not wasting resources. That's the idea behind doing lazy, lazy attributes or lazy properties. Just like we have lazy iteration with generators, for example. So now that I have that, I want to print out the results. So I'm going to say print, and I'm going to use a formatted string. And the first thing I'm going to print is the URL. Then I'm going to tab over and I'm going to print the size. So for the size, I could just print page.page size. But keep in mind what's happening at this point. When I call page.page size, it's going to now access the property page size. So it's going to call this method. At this point, it's going to download the page. So when the print statement tries to interpolate page.page size, that's when the page is going to be downloaded, not before. The other thing too is that the page size is going to come back in bytes, and it could be big, so I want like that 1000 separated, that underscore that we use. So to do that, I'm going to show you, we can just use the format function. So we're going to format page.page size, and we're going to just specify the underscore in the formatting. So now we have that interpolated, and the next thing we want is the elapsed time. So elapsed time is going to be the page dot, what did we call it? I think we called it time elapsed. So time elapsed. So we're going to interpolate that. Now time elapsed is going to be a float that's going to contain the time in seconds, but it's going to have a bunch of milliseconds as well. It's going to have decimal, really, I should say. So I'm going to also format this, and I just want 2 digits after the decimal point. And then after that's done, we'll just say this is in seconds. So that should do it. Let's try it out. All right, so we have an attribute error. What's going on? Web page object has no attribute time elapsed. Yeah, I probably have to spell it right. So let's do it again. Okay, so as you can see, it actually took a little longer to write this loop, because now it actually had to download the page. And as you can see, Google took 0.18 seconds to download. Python took 0.19 seconds to download. They're pretty small pages. And then Yahoo.com is a huge page. 528,000, and it took 0.77 seconds to download. So this is a more complicated example of using properties and calculated properties and doing lazy loading and caching and stuff like that, but hopefully it starts giving you an idea of how powerful properties are. But also hopefully you get an understanding of when you might or might not want to use a bare attribute, right? So very often when we write classes in Python, we're going to use bare attributes until such a time as when we need them to be properties. Then we can transform them into properties at that time without breaking backward compatibility. All right, thank you for watching, and I'll see you in the next video.